Hello, my name is Anna Bergeron, and today I will be discussing some elements that bridge the relationship between calculus and statistics. So what I want you to do is take a minute and reflect on terms that come to mind when you think of probability and statistics. So you've probably heard of and think of terms like mean, median, and mode, normal distribution, standard deviation, or random samples. Maybe you think of graphs like histograms or box and whisker plots. You may think about probability and instances of like flipping a head when you flip a coin or rolling a 3 on a dice. These are all common themes of probability and statistics, but I bet none of you had the first thought of calculus. Well, today I want to show you that calculus is essential in the probability and statistics that we are doing. So let's look a little deeper into some probability where calculus would be important. So I want to start with the scenario on the left. This scenario is probably a more common scenario that you've seen before. If you were looking for the probability of getting 2 heads when flipping 3 coins. A problem like this has a set number of solutions. So this is discrete because we can list out all of the possibilities. And so we can do that now. If we think about having 3 coins and we list out our probabilities, we would be making a list that looks something like this. Oops, sorry, that should be tail, heads, and then all 4 of them being tails. So this would be all of the possibilities of how these 3 coins would flip. So then your options of getting 2 heads would just be the areas where I have 2 H's. So that means that the probability would be out of my 8 choices, 3. So then the probability would be 3 8s. So now let's look at another scenario. So if we look at the next scenario on the right, it's asking you to find the probability that you would wait less than 10 minutes at the doctor's office. Well, could you list out, like we did on the first example, could you list out all the possible options? You could start to write, but you would really quickly find out that there are way too many options because you can't just consider waiting 1 minute, 2 minutes, 3 minutes. You'd have to consider waiting 1 minute, 10 seconds. 1 minute, 10 seconds, 5 milliseconds. So there are too many possible options for this problem. So there has to be another way to solve so that we don't spend the rest of our lives writing out all the options to this problem. So let's start talking about what this other option would be. So with a problem like this scenario, we're working with a continuous variable, meaning that there's an infinite number of options between 2 intervals. So between waiting 0 minutes and let's say 25 minutes, there's an infinite number of possibilities in there. So what we would want to do is we want to take a sample in order to create a histogram. So in this case, if you took 100 samples of how long people waited in the doctor's office, we would create a histogram that looks like this picture here on the right. So then what we would want to do from there is create a more accurate histogram by taking more and more samples. So the more samples that I take, the more accurate my histogram will become. So here I took more samples to make this graph, and then I took even more samples to make this graph below. So then once we take all of these samples, we're able to create what they call a problem density curve, or problem density function. So let's talk about a little more what a probability density function is. So a probability density function is a function that's area between an interval A and B, tells us the probability of that event taking place. So for instance, if we think about the curve that we created, so we had that curve. Let's say we wanted to figure out the probability of waiting less than 10 minutes. So we would find 10 minutes on our graph, and to wait less than 10 minutes would be the area from 0 to 10. So when you're looking for this area, could you think of, or what would be a way to find the area under this curve within these limits. If you need a hint, think calculus. Something that you probably did a lot in calculus would be integrals. So we can use integrals to help us find the area underneath the curve, which is going to help us find the probability that we're looking for. So let's look at an example. Let's talk about everybody's favorite app right now, TikTok. Now we know TikTok is very exciting because TikTok videos moved from being a maximum length of 6 seconds to now a maximum length of 15 seconds, which is huge. So we know that no matter which video you have, that means that length of the video has to be between 0 and 15 seconds. So we can make a probability density function. So for instance, just a guesstimate, but our probability function may look something like this from 0 to 15. So that would mean all the videos would be between 0 and 15. And one of our requirements for a probability density function is that the entire area underneath the curve equals 1. And that's what we would have here in our function. So if this is the function, here, we have 1 over 900 times x squared minus 15 on the interval 0 to 15, because our video can only be between 0 and 15 seconds. So let's say we want to figure out what's the probability when I open the app that I find a video that is between 5 and 10 seconds long. So in our graph, that would be something like finding the area between 5 and 10 seconds. So I'm looking for this area between those two values. So let's use calculus and let's use an integral to help us find that. So if I want the probability that my video is between 5 and 10 seconds, I would be taking the integral of my function from 5 to 10. 5 to 10. So my function was 1 over 900 times x squared minus 15. So when I take this integral, I would start by integrating x squared minus 15. So I would get x cubed over 3. This should look familiar with all of our, I'm sure, our ton of practice integrating in calculus. So then when I solve, I would get 10, 15 times 10 minus 5. Right, we're just plugging in those bounds, those limits into our integrated function. And when we solve that out, we would get 0.241, which means there is a 24% chance that when we open TikTok, that first video that we look at is going to be between 5 and 10 seconds long. So what if I'm impatient and I only want videos that are shorter than 8 seconds? So I could calculate the probability that the video that I'm going to watch will be under 8 seconds. So that would be the probability that x is less than 8. So your original thought would be, well, x is less than 8 means I go from negative infinity to 8 of my function. But remember, in this problem, we have bounds on what our x value could be. So we can't use negative infinity because we said that TikTok videos can only be between 0 and 15 seconds. So our lower bound here is going to be 0 because that's the shortest amount our video could be. So just like before, now I'm going to take the integral from 0 to 8. And then I will evaluate it. Nice part is we already knew what our integral was, but if I was to evaluate that from 0 to 8, I would get 0.056. So that means that there's only a 5 0.6% chance that this video is going to be less than 8 seconds long. And let's be real, we all know that we never make an 8-second video. We usually end up making a bunch of 15-second videos all streamed together. So we knew it was pretty unlikely that we're going to find an 8-second video. So you're probably thinking, well, what other probabilities are continuous functions? So maybe take a minute, see if you can think of a continuous function on your own that you would like to solve. Maybe you want to know the probability of the length of time you'll wait for your Starbucks coffee, or the probability that your friend's tweet will be under 100 characters, or the probability that your pizza will be delivered before your friend comes over. So all of these can be calculated using integrals and calculus. But the good news is, right, when we first started talking about this, we talked about the fact that our graph has to be bound from A to B. So all of the area under our curve equals 1 bound from A to B. Well, the good news is that doesn't limit us on being able to solve. Solving this way uses a bounds A to B, but we can solve a bunch of other curves and variables just using different calculus that we've seen before. So if you think of something like the exponential distribution, that is not bound from A to B, but we could still use our knowledge of calculus to help us solve this probability. The chi-squared distribution and the gamma distribution. All of these are types of probability that we could use calculus to help us solve. Now you may be thinking, well, all of these graphs are two-dimensional. Can we only use calculus and integrals on two-dimensional graphs? And the answer is no. Just like calculus, we are not limited to 2 dimensions when finding the area underneath the curve. Yes, calculus will actually allow us to do joint probability functions. So now instead of having one variable, we can have 2 variables that we're solving for. So now let's look at an example of what a joint probability function would look like. So somewhere we all love to eat, McDonald's. Yes, great food. But maybe sometimes you wonder, would it be faster if I went and picked up my food, or if I went through the drive-thru? Well, that would depend on how many people are also using that avenue. So we could figure out the probability that somebody is using the drive-thru, or the probability that someone is using the cashier. But what we can do is solve for those 2 joint probabilities taking place. So we have our function here. And just like in calculus, when we had 2 variables and we're solving for the area underneath the curve, we would need to take a double integral. We're going to do the same thing here when we solve. Yes, so we have the probability of x, which represents that the time the cashier inside is being used, and the probability of y, which is the probability of that the time the drive-thru is being used. So what if we wanted to know what the probability is that both facilities are being used less than half the time, right? That matches up with what the statement that I have here. So I want to figure out the probability that they're being used less than half the time. So I'm going to take the double integral of x and y from 0 to 1/2. So I would take my function, and this is probably looking so familiar to you because this is just using calculus to help us figure out the probability. And what we would get 1/2 is that when we take our double integral, we find out that the probability of both of these being used, both the drive-through and the counter, are busy half the time is just 5%. So that means that the two of them being used at the same time for less than half the time is 5%, meaning that the other 95% means that they're being used more than that. So that's good to know when we're thinking of which options or how busy are both of them. Maybe we're trying to figure out if that's the best store to go to. Well, now, what if we wanted to just focus on the drive-through or just focus on the counter? We can still do that with the help of calculus. So if I wanted to know about just one factor, meaning either the drive-through or the counter, I could use what's called a marginal probability density function. And that would be these two functions here, right? So this is the function in terms of x, meaning in terms of going inside to the cashier. And this would be the function in terms of y, which is going through the drive-through. So let's figure that we only want to know the probability that the drive-through is being used less than half the time. So we can figure that out. So we have the probability that y is less than 1/2. So again, we're going to take our function, and like our equation said, so from 0 to 0.5, we're doing just the y value. We're just looking at that marginal density function. So then I would have from 0 to 0.5 of 12. And remember, we now don't have an x value because we're just looking at this part of our function. So when I solve this, if I solve this, again, using our knowledge of integrals, I would have and I would get, so that means that 31% of the time our drive-through is being used, or has half the time, right? So half the time, 31% means that 31%, sorry, let me rephrase that. So 31% of the time, if we were to go in there, there's a 31% chance that our drive-through would be being used, which is pretty good. Not a bad situation to be in when you want to go to McDonald's. It's not a bad probability that it's being used or not. So, obviously this is not a deep dive into statistics. We only looked at a couple of examples and really just focused on probability in this section. But hopefully you can see the importance that calculus plays in probability and statistics. And as we continue into this class, I hope you continue to find ways that calculus helps us in our class.